Okay, so this is for integrated math, fundamental counting principles. You guys are lucky enough to have Miss Badger watching after you guys today, so make sure you thank her because she doesn't have to be doing this. So, fundamental counting principle you should have in your notes from yesterday. If there are Q ways to do one thing and P ways to do another, then there are P times Q ways to do them both. Now, I didn't realize this when I printed out the worksheet, but like the first 8 problems all have the same answer. So here we go. Now, ideally, this is what I want you to do. I want you to actually work on these by yourself. I want you to try them and only use this video when you get stuck and aren't sure what you're doing. Then you can fast forward or rewind to the part that you're stuck on, and then go back yawn to doing it by yourself. So, number 1. And they're only like 20, but they're quick. Okay, and if you guys don't finish it, it's fine. We'll have plenty of time next week. So a bag contains 2 real diamonds and a fake diamond. You randomly pick a diamond for your friend and then pick another for yourself. Now here's the thing. Whether or not the diamond is real or not is irrelevant. What we need to know, though, is that when you reach in and grab it, there are 3 choices that you can grab. When you grab in that second time, there are 2 choices. So there are a total of 6 possible choices. And if we ever, and I'm just going to quick show you, you could do, I showed you guys yesterday the option tree or the outcome tree. So if I pick, so my first pick is either going to be, so remember I have 2 real and 1 fake. So if my first pick is a real diamond, so I have 3 options, real, or fake. If I choose a real diamond, then my next 2 option is real or fake. Real or fake. Now I chose the fake diamond first, then my 2 options are real or real. So how many total options are there here? Well, there's 1, 2, 3, 4, 5, 6. See how I end up with 6 options down here? Boom. But 3 times 2 is easier, so that's what we do. A basket contains 1 apple, 1 peach, and 1 orange. You randomly pick a piece of fruit to eat. It doesn't matter which one you pick. What we know is that when you pick, you have 3 choices. And then you get a little nippy later on. Nippy is cold, so I don't know what that was supposed to mean. Nibbly, maybe. You're hungry, so you eat a second one. But now, there are only 2 pieces of fruit left. And so that's 6. Again, I'm going to really quickly show you that option tree. So if I can either, my first pick is either going to be a peach, an orange, or an apple. If I pick the peach first, my remaining choices are an orange or an apple. If I pick the orange first, it's a peach or an apple. If I picked an apple first, it would be an orange or a peach. So my options here are peach then orange, peach then apple, orange then peach, orange then apple, apple then orange, apple then peach. 6. The chess club must decide when to meet for practice. The possible days are Tuesday, Wednesday, Thursday. That's 3 times, or 3 or 4. That's 2. So again, Tuesday at 3, Tuesday at 4. Wednesday at 3, Wednesday at 4. Thursday at 3, Thursday at 4. 3 times 2 is 6. I know, sick of the 6s. A bag contains 2 real diamonds. We already did this one. There is 1 quarter, 1 dime, and 1 nickel in your pocket. 3 coins. You randomly pick a coin and place it on the counter. You then pick a second coin. Well, after you've taken 1 out, you only have 2 left. Those 6 choices are quarter then dime, quarter then nickel, dime then quarter, dime then nickel, nickel then quarter, nickel then dime, 6. There are 2 dimes and a nickel in your pocket, and you do the same thing. The fact that you have 2 dimes doesn't change, because you can go dime, 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 nickel, dime, 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 nickel, because they're 2 different dimes. I guess arguably you could say that because they're the same thing, you'd go 2 times 2, because you can only pick a dime or a nickel the first time, and then a dime or a nickel the second time. That's 4. But we're going to go with 6 as the correct answer because the 2 dimes are different. 2 apples and a peach. Again, 3 times 2, 6. If you wanted to say, well, if you're just looking at the piece of fruit you eat, you can either eat apple peach or peach apple, right? Or you could eat apple apple, I guess, too. But I'm going to go with 6. Single scoop waffle cones or bowls, 2, 3 flavors. 2 times 3 is 6. Hopefully you all know that 2 times 3 is 6 now. A new car is available in sedan or hatchback. That's 2. And then available in red, white, green, black, or yellow. Ooh, lucky day. There are multiple colors. 1, 2, 3, 4, 5. So my options here are sedan red, sedan white, sedan green, sedan black, sedan yellow, or hatchback red, hatchback white, hatchback green, hatchback black, hatchback yellow, or 2 times 5, which is 10. There are 10 possible outcomes. Bagel Shop has 3 types of bagel. Each bagel can be ordered with no spread, butter, or cream cheese. Also 3, so we got 3 times 3 is 9. You flip a coin 7 times. Now, each time you flip a coin, you have 2 choices. Heads or tails? 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 That's 2 to the 7th power. Or a total of 128 different outcomes. And the chess cup's practicing again, so we're going to skip that. 6 rooms in the house need to be painted. Each room can be painted white, yellow, or pink. So we have all 6 rooms, 3 different colors. 6 times 3 equals 18. So there are 18 possible outcomes of those rooms getting painted. You flip a coin 7 times and then roll a 6-sided die. So how many different outcomes can you have? So we know that flipping a coin 7 times gives us 128. Kind of slick there, right? Work harder, not smart. Work smarter, not harder. Right. And then when I roll a 6-sided die, there's 6 other ways that could end up. So if I flipped all heads, that's one of the 128 ways that I could flip a coin. But there are 6 versions of that, because I could flip all heads, roll a 1, all heads, roll a 2, all heads, roll a 3. So each of those 128 different ways to flip the coins then has 6 additional ways that it can outcome purely because we're rolling a dice after it. So we go 128 times 6, and that gives us a total of 768 outcomes. A spinner can land on red or blue. You spin 5 times and then roll a 6-sided die. So again, we're going 2 times 2 times 2 times 2, because that's the red or blue, times 2. So there are 32 different ways the spinner can land after spinning it 5 times. You know, red, 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 blue, red, 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 blue, blue, red, blue, blue, red. Anyway, you get the point. There are 32 different ways that can happen if you're spinning it 5 times. You're then rolling a 6-sided die. And so simply by that one extra action of rolling a 6-sided die, after the 5 spins, you get 192 different outcomes. Flip a coin 9 times. Remember how I said it was 2 to the 7th last time? This is going to be 2 to the 9th, or 2. It's going to be 512. When a button is pressed, a computer program outputs a random even number, greater than 0 and less than 12. You press the button 5 times. So first we need to figure out how many outcomes there are. So 0, and I'm just going to write down the even numbers. 2, 4, 6, 8, who, do we, a pre. I'm sorry, 2, 4, 6, 8, 10, 12. Well, it's got to be greater than 0 and less than 12. Notice it doesn't say less than or equal to, it says less than 12. So the even numbers greater than 0 and less than 12 are 2, 4, 6, 8, 10. There are 5 of them. So we're hitting that button. Every time we hit it, it randomly generates that number. There are 5 different options. And we hit it 5 times. So that is 5 to the 5th power, or 3,125 different numbers. Because it could be 2, 2, 2, 2, 2, 2, 2. You get the point. Okay. Nope. Nope. Move this way. There we go. 7 books need to be placed on a shelf. You randomly arrange the books on the shelf from left to right. This is a little tricky. And this is kind of, I want you to work really, really hard on this one before looking at the answer. Because this is kind of like the next level. Okay, so hit pause, spend like 5 minutes on this. Struggle, 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 and come back. So, if I'm placing the books on the shelf from left to right, I don't have 7 options in each time. That might be the easy way to think about it. Well, I just go 7 times 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 7. I don't even know if that was 7, but you get the idea. 7 to the 7th power. But the fact is, when I place the first book, I have 7 options. But now, how many books do I have left? 6. So what we'll learn is later on, this is called a factorial. And because the order doesn't matter in which I place them, what matters is that I have 7 options for the first one, 7 for the second one, and so on and so forth. And that is going to be a total of 5,040 options. Bag contains tickets ordered 0 to 9. One at a time, you pick 5 tickets without returning the tickets to the bag. To create a password, you write down each number in the order picked. How many different passwords can I come up with? Just 10 numbers. And that is 10 numbers because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first time I pick a number, there are 10 different options. Then there are 9 different options. Then there are 8 different options. Then there are 7 different options. And when I reach in to pull out that 5th ticket, there's 6 tickets in there. So there's 6 different ways that could happen. So what I do is I go 10 times 9 times 8 times 7 times 6. And just by picking out 5 numbers from a bag randomly, there are 30,240 different password options that I could have. And number 20. A pizza stand offers hand-tossed and pan pizza. Customers can add any combination of the 8 available toppings. So what we're going to do is we're going to go, how many different ways can I put together 8 different toppings? So included in this, in the different ways that I can put those toppings,
your skin isn't just skin. It's a beautiful reflection of everything you've been through. Dove Body Wash with 5 skin conditioning ingredients boosts skin ceramides renewal for hydrated, physically moisturized skin. Renew the love with Dove Body Wash. And now introducing new Dove Body Lotions.
Verizon is going ultra, and now you can too with the offer you just can't miss. For a limited time, get a 5G phone on us.
Delightful.
With no trade-in required. Love it. What's not to love?
So there are 8 available toppings. But here's the thing.
Okay, sometimes when you're working remotely, ideas can be tough to get across.
For the hand-tossed,
With select HP devices enhanced by HP Presence,
you can get topping number 1. You can get topping number 1 and number 2. Get topping number 1 and number 3. Topping number 1 and number 4. Topping number 1 and number... And so 1 and 6, 1 and 7, 1 and 8. And then you get 1, 2, and 3. 1, 2, and 4. So because there's not a limit on this, this is called a permutation, and something that I didn't go over with you. So you guys don't know how to do this. But if you want, for extra credit, you can draw out the opportunity tree, like the option tree, for just one of the pizzas. Figure out how many ways you can put together 8 different toppings. Because here's the thing, there's no limit on whether you're getting 8 or 7 or 6 or 5 or 4 or 3 or 2 or just one topping. So if you want, I'll give you 10 extra credit points for putting together that tree. And I will see you guys on Monday. If not, I hope you guys come and see the show. Have a wonderful weekend, everyone. Bye.